Okay, having a look at our week 4 quiz for the maths methods, looking at some logs, some average rate of change, some derivatives and equations of normals and tangents. So to start with, we've got some logs. Now we've got all base 5 here, so we're able to simplify that by bringing that together. When we're adding, we multiply. When we subtract, we're dividing. So we've got log 5, I'm going to do the 10 times 2 over 4. Now 10 times 2 is 20, divided by 4 is 5, so I end up with log 5, 5, and I know that log 5, 5 is 1. Here we've got quite a few to bring together. We've got a few coefficients out the front, so my first step will be to take them to the top, log 6, and then 3 times 3 to the power of 3, and then we've got plus our log 6, 6. Now we could just simplify that to 1 straight away, but I'm just going to do it in one shot. And we've got here log 6, 9 squared plus log 6, 3. So simplifying those ones with the powers, we've got log 6, 27 plus log 6, 6 minus log 6, 81 plus log 6, 3. So I now need to bring them together. So the plus I'm going to multiply, and the minus I will do the division. So we end up with log 6, and we have 27 times 6 times 3, and that's over 81. Now I know that 27 times 3 is going to give me 81, so I can cancel them out, and that gives me log 6, 6, which is equal to 1. Here I've got 2 minus log 325 plus log 39. I'm going to change that 2 to log 3, 3 squared, because I know that log 3, 3 is 1. And if I've brought that 2 down, 2 times 1 is 2. Then I've got the log 325 plus log 39. So I'm going to bring that together. So I've got the 9 there. So I end up with log 3 of 9 times 9 on the top, 25 on the bottom. So I've got 81 over 25. I'll check if that simplifies on my calculator. So if I use my fraction button, 81 and 25. Doesn't simplify any further, so I'm just going to leave it like that. Solving our log of x minus 7 equals log 5. If we've got the log, that means that this part must be equal to that part. So we can write x minus 7 equals 5. So our x must be equal to 12. Here we've got 4 log x minus log x equals 64. So I'm going to change this to x to the power of 4 first. And then I've got log x, log 64. When there's no base listed, you assume it's base 10, but we don't actually need that. But we've got log, so that'll be x to the 4 over x, log 64. Now when that simplifies, that will be x to the power of 3. Now if we've got that log on both sides, we can then say x to the power of 3 must be equal to 64. That's 4 to the power of 3. Therefore, x must equal 4. Here we've got finding the average rate of change between x equals 1 and x equals 5 for y equals x cubed plus 3x squared minus 5x plus 4. So I want to find out my y of 1, my y of 5. It's a long equation, so I'm going to pop that function into my calculator. So I'm going to put x to the power of 3 plus, x to the power of 3 plus 3x squared minus 5x, and I've got plus 4. So I've got that into my calculator, graph it, and I want to find second trace value. I'll put in 1, so I get 3, and then I'll put in 5, I get 179. So when I do my average rate of change, it's going to equal that 179, take 3 over, and we've gone between 5 and 1, so 5 take 1 is 4, and 179 take 3 is going to give me 176. So 176 divided by 4 gives me 44 as my average rate of change. Then we've got a first principles question. So using first principles to do x squared plus 4x. So I'm going to do my f of x plus h first. So I get x plus h squared plus 4 outside of x plus h. I'm going to expand that, x squared plus 2xh plus h squared plus 4x plus 4h. And then I'm going to put that into my f dash x is equal to the limit as h h approaches 0 of f of x plus h minus f of x over h. So I've got the limit as h approaches 0 of x squared plus 2xh plus h squared plus 4x plus 4h, and I'm subtracting x squared, and I'm just going to do this in one go and write minus 4x because I'm subtracting the x squared, I'm subtracting the 4x over h. I can cancel out the x squared and the minus x squared, the 4x and the minus 4x, so that gives me the limit as h approaches 0 of 2xh plus h squared plus 4 over h, and I must have missed a h up there, forgot to write my h. So now I'm going to have to take out that common factor of h, 2x plus h plus 4 over h, so I can cancel that out. So I end up with the limit as h approaches 0 of 2x plus h plus 4. As h approaches 0, that will go, so that will equal 2x plus 4. The next one has find the equation of the tangent and the equation of the normal for y equals 3x squared minus 5x plus 4 at x equals 1. So first step, I'll do my derivative. So I get 6x minus 5 is my derivative. My gradient at 1 would then be 6 take 5, which equals 1. So that's my gradient of my tangent. My gradient of my normal is going to be negative 1 on 1, which is just negative 1. So now I've got the two gradients that I need, but I also need a y coordinate. So I need to sub in 1 into here. So 1 squared is just going to be 1 times 3 is 3. Take away 5 is negative 2 plus 4 is 2. So my coordinate is 1, 2. So I'm going to find out those two equations now. So using my y equals mx plus c, I'm going to put in first, I'm going to do my tangent. So I've got 2 is equal to 1 times 1 plus c. So then my c must be equal to 1. So y is equal to x plus 1 is my first equation for my tangent. Then for my normal, I've got that minus 1. So I've got y equals mx plus c. So I've got 2 is equal to negative 1 times 1 plus c. Negative 1 times 1 is negative 1 plus c is 2. So that means my c must be equal to 3. So then my equation of my normal would be negative x plus 3. And the last question in this set is for the graph x cubed minus 3x squared, determine whether the graph has a positive gradient. So having a look at that graph, to start with, we've got x to the power of 3, and we're taking away 3x squared. Whoops. Square root of 3, take 3x squared. And so then I'm looking at where it is positive. So I've got a positive gradient here to 0. And then when we get to this point, so I need to find out, that looks like it's 2. If I do my trace that, it looks like that is at about 2. So what I'll do to check that is do the derivative. So I've got 3x squared minus 6x. And it looks like that has a gradient of 0 at 0 and at 2. So I'm just going to sub that in and check. So that's my y dash. So if I sub in 0, I will get 3 lots of 0 squared minus 6 lots of 0. So that's 0. And then the other one I thought it was 2. So I'll go 3 lots of 2 squared, which is 4, minus 6 lots of 2. 3 times 4 is 12. Take 12 is equal to 0. So yeah, 2 was the other one. So I had those two values. So when x was less than 0, so on this side, we had a positive gradient, and then when x is greater than 2. So I could write that as less than 0 and greater than 2 is where it has the positive gradient.